This patch of grass looks just like any other patch of grass on the highway, so you might not realize that it's been engineered to prevent flooding.
A lot of our community is engineered with a purpose.
There is a lot on our landscape that you wouldn't even realize is a stormwater control measure until you see it filled up with water when it's raining.
Check out this grassy swale next to a parking deck. It's intentionally sloped to direct water flowing off the parking deck and sidewalk to this drain structure, while absorbing some of it along the way. Even if it doesn't look like much, if it wasn't there, you would definitely notice when it rained.
Development does a lot to our land when we're building upon it. So I want you to imagine if you have a big open field, there might be grass, there's soil, there's trees, maybe sand or river, all kinds of surfaces that are porous, meaning there's holes in them. So when it rains, the water is able to infiltrate or sink into the ground, soak it up like a sponge. But when you put a parking lot over that formerly grass area, it's no longer able to sink into the ground and it's just gonna run off.
You've heard the song Paved Paradise, put up a parking lot, right? Well, I'm not saying parking lots are not necessarily, because they are. But when that happens, the net effect is you generate a lot more runoff, a factor of 10 more.
So how do we deal with all of the water flowing off of all of the things that we've built? We've engineered stormwater control measures.
The Roman methodology, the Roman mentality was get the water out of here. That's where the term highways come from. They were on the high points because they wanted the water off those roads. And so for millennia, truly, we worried about just getting the water out of here, and that's how runoff was managed. But what that ended up leading to is if you went far enough downstream, you'd start having local communities getting flooded.
In addition to downstream flooding, fish kills in the 1990s due to excess nitrogen in the Neuse River Basin highlighted the need to manage for more than flooding. Now we have a variety of ways to decrease volume, speed, and contaminant levels in stormwater runoff, and they all work a little differently.
Stormwater control measures, very sort of simply, they will stop, temporarily hold, and then usually slowly release runoff.
And they can be tailored to fit what a developed area needs. Too many nutrients in the runoff? A wetland is a good option. Need a low-maintenance way to manage runoff from a parking deck? A grassy swale might be the answer. High-volume flows? Maybe a regenerative stormwater conveyance like this one would do the trick. And maybe you've heard of a rain garden.
It's our most common practice on campus. Engineers, we like to refer to them as bioretention cells. You tend to see them in parking lots because they also satisfy landscaping requirements. The idea is there's a media, which is a specialized soil mix.
This soil mix can support plant growth, but also allows water to pass through quickly, and it traps pollutants like nitrogen and phosphorus. Below the rain garden is a collector pipe that delivers the water to a nearby creek.
We had a pretty significant, intense rain about 2 hours ago. I thought we might see some water ponded in it. No, I love it. I love it.
But even with measures like this in place, flooding is still a problem. And as the climate changes, we're dealing with even more stormwater.
The hurricanes have been moving slower typically across our state and dumping a lot more water than historically has been observed.
For example, Goldsboro, North Carolina has been hit with 3 record-breaking storms since the 90s, with hurricanes Floyd, Dennis, and Florence.
Now you can calculate the odds of that just randomly happening. And I mean, it's possible, but you have to understand that it might happen once over the course of recorded history. So either we're really unlucky, or there is a trend, a new trend or a pattern of rainfall that is really impacting us. With the storms that we are experiencing, we're observing that stormwater control measures are failing. And by failing, I mean that the water level rises and it overtops and causes them to erode or blow out. A common term is they blew out. And then it just doesn't function at all.
It's very important to figure out what are the points of failure in our current stormwater control measures and how we can build them to be more resilient against failing.
Researchers like Naomi are taking a look at existing measures to figure out how to make them more resilient for the future. This is one of her research sites at a rest area in Alamance County, right off of I-85.
A lot of sediment built up there in the forebay.
Right now we're standing in the riffle pool of the Regenerative Stormwater Conveyance System, which we call RSC for short because that's kind of a mouthful. Basically, it makes the flow during a rain event, the stormwater runoff, less erosive by slowing the water down. And it is capturing water from the highway as well as from this parking lot. It's kind of in a bowl. So this is at the lower elevation, and all the surrounding water that's at a higher elevation is gonna roll down into it. Right now we're setting up our total station, and that's a surveying device. So we're gonna use the total station to shoot a laser at a mirror effectively, and then it'll send it back and tell you what the elevation and distance from our setup point is. And then once I have several points, I can upload that into a program called AutoCAD, and there I can generate a 3D surface of this land.
Naomi and Caleb worked their way across the site, mapping out the shape of the RSC for Naomi to compare to historical measurements from when it was built.
Got it.
Yeah, this part gets kind of repetitive.
Stormwater control measures like this RSC aren't a set it and forget it solution. They have to be maintained.
Wow, that's filled up with a lot of sediment. Yeah, there doesn't look like there's any ponding left. It's not gonna function as well as it is intended to. You know, we can design them however we want, but if they aren't maintained, they're not gonna be resilient.
Comparing measurements of the current elevation with historical data allows Naomi to calculate how much sediment needs to be dug out in order to return this RSC to the way it was designed. With the data she's collected at multiple sites, Naomi can create models of stormwater measures and test them to see when they fail.
And the way I can characterize whether they're failing or not is if the flow in from the storm is equal to the flow out of the storm, because that's what we do not want. We don't want the same amount that's coming in to be coming out immediately. Modeling is incredibly useful in this work, and just a few clicks of a button, I can completely redesign this bioretention cell or a regenerative stormwater conveyance system. If I were doing this in the real world, that would take me months and lots of money to do. I can have real storms, but I can also make my own storm. I can't do that in the real world, so it gives you the capability to model things that you wouldn't be able to otherwise, and it gives you results in seconds.
What Naomi discovers could help protect communities in the future.
With climate change happening, it's important to recognize that what a stormwater control measure might be designed to withstand today might not be the same storm that we're seeing in 10, 20 years from now. And that might sound like a long way away, but we don't know how fast climate change is going to impact us. And even in 10 and 20 years, you don't want to have to deal with the cost and the inconvenience of replacing the stormwater control measures. So it's better if we can build them to function today and, last a long time in the future.
Thanks y'all for watching this video, and if you want more where that came from, check out our channel, Sci and C. Stick around.